Hello, my name is Li Hao. Welcome to Advent of Code 2020. So Advent of Code is a series of programming challenges that is on the Advent calendar. And every day there is one challenge, which part 1, part 2, and each part gives you a gold star. So within 25 days, you'll collect 50 gold stars. And your goal is to collect that gold star because it's called a gold star. Yeah. Okay, so today we are going to do day 8. So what does that mean? You have missed, this is the first time watching this, that means that you have missed out 1, 2, 3, 4, 5, 6, 7 days of Advent of Code, right? So if you want to watch that, click here, link will be here, and we are going to do day 8. So let's go for the calendar and let's look at the question for day 8. Well, day 8, handheld halting. Well, your flight to the major airline hub reaches cruising altitude without incident, while you consider checking the in-flight menu of one of those kid drinks that come with a little umbrella, you are interrupted by the kid sitting next to you. Naughty kid. The handheld game console won't turn on. What? They ask you if you can take a look. You narrow the problem down to a strange infinite loop in a boot code, your puzzle input. So your puzzle input is a boot code of the device. You should be able to fix it, but first you need to be able to run the code in isolation. The boot code is represented as a text file with one instruction per line of the text. And each instruction consists of an operation, accumulate, jump, and no operation. Okay, so accumulate increases or decrease a single global value called accumulator. So by the value given in the argument. So it will be an operation and then an argument. So for example, ACC plus 7, which means that you accumulate by 7, right? So it starts with 0 and then after one instruction, it will immediately increase and then the instruction will move to the next instruction below it. Right, jumps will jump the new instruction relative to itself. The next instruction to execute is found using the argument as an offset from the jump instruction. So jump plus 2 will be moving 2 steps to the next instruction. Jump plus 1 will continue next, right? So it will always move next. So jump plus 2 once 1. So it's the next one, right? We'll skip the next instruction and go to the next one. And jump 1 will be the go 1 next step, actually will be the next immediate instruction. Jump minus 20 will be actually moving 20 lines above, right? So no operation, no op, does nothing. So you just continue execute. So for example, if you consider the following program, you will start with no operation and accumulate plus 1. And then jump 4 steps, 1, 2, 3, 4, accumulate plus 1. Jump minus 4 step, 1, 2, 3, 4, accumulate 3. And jump minus 3 and then go back 1, 2, 3 and continue here. Right? So I guess that's where the infinite loop happens, right? So this explains how it happens. So there's an infinite loop. So your program will run forever. At the moment of the program tries to run away any instruction a second time, you know it will never terminate. So immediately before the program would run an instruction a second time, the value of the accumulator is 5. So start from 1 is 0 and then we plus 1. And then we jump 4 step with plus 1, 2, 3, 4 step. 1, 2, 3, 4 step with plus 1, then it will be 2. And then minus 4, 1, 2, 3, 4. And here, so plus 3 will be 5, and then minus 3 will back to the same position. Then right before we reach the same position that we've visited before, we have 5 in the accumulator. Right, so run your code and then find out what value is the accumulator when we execute the same instruction the second time. This is a puzzle input. Let's download it, save input text. And we're going to copy this input as day 8. And we're going to create a new file, touch day 8. And we're gonna code this file, code it, and no more n. Okay, so what now? What now is that we're gonna close whatever unnecessary file. If you want to know what's there, please watch the previous video. So what we're gonna do here is gonna read the content of file. Fs read file sync. The file name is day8. Coding is UTF-8. This will be the content. Right, and then, okay, so there'll be list of instructions. Okay, I guess let's take a look what we downloaded. List of instructions, right? Accumulate, jump, or no op, and then a parameter, right? So you know me. What we're gonna do is to use regular expressions, right? So content.split dot map. Each line we're gonna use regular expression. So line.match. It starts with ACC or no op or jump JMP, right? And with a space, and then it's either plus or minus, and then numbers as many times as possible. That will be the end of the regex. Sorry, and then right. So what we have in the match is that the first one is the instruction, and the next one will be the argument, or ARG in short, right? So we're gonna return this instruction and argument as an array, right? And then, so this will be the instructions set. And what we're gonna do is that we're gonna loop through the instruction. We're gonna run step by step. So our program start with index 0, and we're gonna execute the instruction at this line, and then we're gonna increment I, right? So I think before that we're gonna have visited index as a new set. So at least this tells us that if we while we are stepping through each of the instructions, we're gonna add this index in as the visited, so that if you encounter it the next time, we're gonna console out the accumulated value, right? So if while we say while we haven't visited the index I, then we're gonna execute the index I. So we're just gonna say index.add. So we're gonna add it first, and we're gonna execute the instruction, right? So instruction of it will be instruction set of the index I, and the first one will be the instruction, and the second one will be the argument, right? And switch based on the instruction. If it's a accumulator, then what we're gonna do is we're gonna add up the argument, right? So we also need a variable called accumulator. Accumulator equals 0, and once we encounter this, we're gonna add the argument, and then we are going to I will be move +1, next instruction, and we're gonna break the switch case. And if we are jump, then I plus the argument, that is the offset that we're gonna go for, and we're gonna break the switch case. And for any other instructions, we're gonna increment I and break, right? And once we reach, we encounter the same index that we encountered before, we're gonna break this while loop. At the end of it, what we're gonna do is we're gonna console out the accumulator, which is how much we have accumulated so far. So I'm gonna run the code, Ah, man, what is this? So probably we encountered an index that is I'm gonna print out I and see what's going on wrong over here. Oh, okay. So actually argument we kind of treated it as a string. Because it is a string and we treated it as a number. We thought it's a string. So we're gonna do here is actually we're gonna convert it as a number. And remove this and let's run it again. 1867. Gonna paste it in. And yes, that's right. It's the right answer. Okay, now part 2. So after some careful analysis, you believe that actually there's exactly one instruction is corrupted. Well, somewhere in the program, either a jump supposed to be a no op or no op supposed to be a jump, right? So no accumulate instructions will harm. Okay, so the program is supposed to be terminate and attempting to execute the instruction immediately after the last instruction in the file. By changing exactly one jump or no op, you can repair the boot code and terminate it correctly. Right, so it's changing either one of the jump to no op or no op to jump. And then after finding it, after we fix it so that it can always reach the end, that means it's terminated. And we're gonna fix it and we're gonna say that what is the value of the accumulator after the program terminates, right? So what I'm gonna do here is that I believe we can kind of brute force this. What that means is that we can try to fix every instruction possible one by one. We fix the first, so in this case, we're going to fix the first no op to become jump, and then we see whether it fixes the code. If it does not, then we're going to try to change the next jump to no op. If it fix, then if it's not, then we're going to try this one, right? So we're going to fix and then revert it kind of so that we can try to fix the other ones, right? At any one time, we're going to fix one. So to do this, what we're going to do here is that we will also at the same time record down all the index of accumulate and jump or jump, no op or jump, right? So that we're going to loop through each of these indexes that needs to be replaced. So I'm going to have to be fix equals a new empty array, and then to loop through the instruction set by using an index I less than length and I plus plus. So if instruction set I is equals to, if the instruction is equals to jump or a no op, then to be fixed will be push with that index. Okay, so now we have all the index that possibly a fix. I'm going to loop through the index to be fixed. Off, okay. And then we can actually fix it, right? So what we'll do is that firstly, we're going to know whether this is a jump or no op. Is jump instruction set equals to jump, right? So if is jump, so we're going to replace it. So instruction set I0, we're going to replace is jump. Then we're going to replace it as no op, or else if it's a no op, we're going to replace it with jump. And we're going to test the instruction set. Test instruction set, right? And if it pass, then that's it, right? We're gonna break. If it's not pass, which means that so the test will try to see whether if it terminates and then prints out the answer. If it's not, then you'll be returning false. Then we'll continue to do the loop. And over here, we're gonna fix it back. So we're gonna swap the jump and the no op around. Right? So the rest is that we're gonna write the test function. So what the test function do is actually what we have done so far, right? We're gonna run this and find out whether function test instruction set we'll test and find out whether we reach the end of it. So it's either we have visited it or I is less than the instruction set dot length. Right, so if we actually fix it, it will be reaching the end of the instruction set. And at the end of it, we are going to see if instruction set, if I is equals to the length of the instruction set, then actually we reach the end. Then we console out the accumulator and return true, so that we can break the for loop over here. If it's not, then we return false. That's too bad. Try again. Right, so let's clear the console and run. Why am I happening? So this is the index. Run. Wow. Takes longer than I thought. Probably we end up in a infinite loop. Oh no. Okay, I'm gonna cancel this. I'm gonna take a look at one good look at what we might have done wrong. Oh, okay, so this condition should be n, right? If either of the condition is not true, then we have to break. Either it's true, then we have to be both of them to be true to stay. Yeah, that's why we keep stucking in an infinite loop because this is no longer true. We have visited it before, but because index is still within the length of the instruction set, we keep continuing to go through the loop. So 13203 sounds like a possible answer. Paste it in and submit. Yay! It's the right answer. Okay, so that's about it. Day 8 of Advent of Code 2020. Please like the video if you like it. Comments down below if you have any questions or you feel that I'm doing something wrong or you have something more better ideas. Tell me down below. Then remember to subscribe my channel because day 9 is coming. Okay? Subscribe so you will know when it's out. See ya!